It's pleasure to welcome you all once again. We are delighted to have Jayant with us today as well. Our previous session was truly insightful and engaging, and we gained a lot of clarity from his explanation and real life examples. So, yeah, and again, fortunate to have him guide us again today. And I am sure this session will provide even deeper insights and learning. Thank you everyone for joining. And with that, I now hand it over to Jayant.
Yeah, thank you, Shivansh, for the kind introduction. Am I audible? My voice is tracking. If it is so, then I will off my video. Can anyone? Audible. Okay. Okay, Arvind also. Okay. Okay, I will keep my video on. Okay, let me share my screen. Can you give the host, can you give the option to share the screen? Yeah, now I could able to share. I think something different option is. I think this is fine. Let's see this one. How was the screen, guys? Am I visible to everyone? Okay, okay. Yeah. Today we are going to see agents, right? The agentic system, how the agents are used, and what all we can understand, and what are their applications, right? Now you might be wondering why we need agents, Chant. We already saw Gen AI, right? We already know LLMs. Now we have ChatGPT, we have Gemini. All these LLMs were there and we are using. Why is agents needed? The concept, right? Now, if I after this session, you will have a broad picture of how the Gemini, how ChatGPT, how Cloud they are working, right? Right now, let's move ahead. Let's move ahead and see. Let's move ahead and understand why we need agents, right? Why we need agents. Let me take the pen. Let me take the pen. Right now you can see here. Let's say you have a task. Let's say you want to do a trip planning, right? Trip planning. Now, in this example, let's understand how GenAI works, and how agentic system works. How both are different, right? Let's see the difference, right? Now, you to for a trip, what all things needed, right? You need to know how much budget, right? And you need to know beforehand accommodation is available or not. You need to know the weather, right? What is the weather forecast there? And you need to know first of all what are the tourist places first, and many other things are required actually, right? Now let's say you want to build with you want to have the planner using GenAI. Then what you have to do? First, let's say you go to ChatGPT. Let's say you are going to ChatGPT and you're asking, I want a trip planner. Then automatically it will understand and it will give complete information according for all this, because now it is also using agents. But what it used to be 1 year before, let's say, now first question you ask, let's say what are the tourist places? What are the tourist places? What let's say I will say places, right? places in some location like this, some location you put here. Then you select some of them, right? Some these places are there. Now what is the budget will be required, and what about some other locations near this? And you will ask the GPT step by step, question by question, question after question, question after question, for the planner, to get the complete planner at the end. Okay, this is the plan for the trip, this is the plan. After 5 6 interactions with the chatbot, we will get the complete plan. Whereas in agentic system, you just will tell a goal. You just tell, I want a trip planner, trip planner to, let's say, to Goa. That's it, guys. That's it. You only have to interact once, only once. And this is a goal for the agent. What, see, agent, what it does, it will take actions on your behalf. It will think on your behalf, and it will make the plan accordingly. Because here you see in GenAI, you are thinking what will be the next step, what I have to ask next, what I have to ask next, what I have to ask next. But here it will ask by itself autonomously, right? Are you able to understand? This is a big thing. This is a very big thing, because now intelligence driven by AI, not you and me. It is reasoning what to do, and it is acting on that reasoning. It is thinking and it is acting, and it is observing also. What is the result of the action? It is observing, and based on that, it again reasoning. Then it again taking the action. Then it will again get the observation. Then again it will reason until when? Until the task is completed. Are you able to understand? Right? This is how agent works. But what this action contains, how it reasons, right? And what exactly these details we are going to see in today's video. Right? You got the picture of the video, what we are going to see ahead. And again, of course, LangChain. I already gave brief introduction about it in the last class, right? How it works and why we are using it and how powerful it is. Right? Now, again, it is helping us today to build these systems. And we have agentic AI, agentic RAG project also. Next 2 days, we are going to do that. These concepts are very vital to that project also, right? And we will understand this concept whatever best possible way in the constraint time, right? And we will go through the documentation only, official documentation only, so that you will get the friendly walk through the documentation, and you can go ahead later if you need further, right? Anyone having any doubt why we are going to learn this agentic? Because it is powerful. It is so powerful that you don't have to do anything. You just have to tell your goal. That's it. Now, let me move ahead and let's see what agents are exactly. What agents are exactly. What agents are, right? Now, you can see here, agent. What is an agent? Agent is a system that uses large language model that we already studied. See, this component we already studied. LLM, right? As a what? How? As a reasoning engine. For what? For what? To get the actions to take, and in what order? What actions to take, in what order? It uses the LLM. Unlike chains, in the last class we built the chains also. See, where chains of actions are hard coded. See, we hard coded the action. First prompt, you can see me. First prompt, then we give to the model. we get the output. Then let's say some other prompt, another model. We hard coded the flow, but here we don't. We just give the input, and model will understand automatically what to do next. We don't hard code anything here, right? Dynamically, it is very important. You see, dynamically decide their next steps based on the context. What is the context here? Context is your problem and the information chart history that the model has, that the agent has. It will understand where the chart history is stored and how the model is taking the actions, right? Going forward. You can see here key characteristics: autonomous decision making, dynamic reasoning, tool integration. Right? We will understand what are tools, adaptive behavior with code also, right? We'll see practically as well. And here you see some example is there. Think of agent like a personal assistant with a smartphone. Personal assistant with smartphone. When you ask them to plan a trip, they don't follow rigid script. Instead, they check weather app to know the weather, search for flights, what are the flights available, read the reviews of the locations, make decisions based on what they find. The assistant reasons about which tool to use next based on the information they gather. Are you able to understand what is an agent now? Right? Right? What is an agent? Yes. Very nice, Kunal. Right? Like that. Now let's move forward. See, we will see the practical implementation. At the end, I will show you, right? This code you don't have to bother. Right? I will see after 4 5 slides, we will understand with practical implementation as well. Now, as I explained this, you see agent loop, planning and decision making. How? First, it receives the query and reasoning. LLM analyzes tool selection. It will select some tool so that it will understand what action to take. See, some tools are available. Like in our example that we have taken for the trip planner, whether some tool is nothing but it acts as an external agent, right? It acts as an external resource so that your LLM can take decisions out of it. And we will go through that also, right? Now we are seeing the life cycle, how the agent gives the conclusion, how it comes to a conclusion. First, it will take the user query, it analyzes with the LLM, it reasons. We saw in the definition that agent uses LLM as a reasoning engine, and it will select a tool based on the reason, and it executes the tool, and from the tool it will get some information, and it will observe the information and it will give whether it is exactly asked by the user or not. If not, then it will again the loop continues. I hope you are able to understand. I hope. Right? Agent node calls the LLM. See what are node? Here tool node is there. Right? Actually, we have some other framework given by the LangChain, which is called as LangGraph. Right? LangGraph, where this agentic module is implemented in LangGraph itself. But LangChain uses only a specific part of LangGraph so that we can build agent very easily. If you want to build complex agents with so much customization that is required for your problem statement, then we go for LangGraph, that is separate module, separate library to build agentic systems itself. Are you able to understand? In that terminology, agent is treated as a node and tool also a node. You don't have to bother about it because it is represented as a node. I talked about LangGraph, right? Now you see calls the LLM with the message history and system prompt. And if LLM response contains tool calls, execute those tools. Yes, if tools are there, then LLM response will contain tools. We'll see practically how LLM response contains tools and how message history is maintained, how the state will help, right? All these we'll see. And what is iteration? Agent calls LLM again with updated context. Yes, if conclusion is not now, if the response is not satisfied with the user, then it will again like this. Some analogy is there. I hope you're able to understand. Right? Now, tools. Tools are functions that the agents can call to interact with external systems retrieve information, and perform specific actions. They extend the agent's capabilities beyond just text generation. Right? These are very, very crucial to understand, because without every component is unique to build the complete system, complete LLM application, agentic application. Every part is crucial here. You see. Now, what are tools? External systems. I think I have to change the font color. It seems. Right? You can see these are external systems. External. What does this mean? Like this, you see one example, you see Wikipedia search. Let's say I want to know some information. Let's say I want to learn what is agentic RAG. What is agentic? Agentic. We already saw generative RAG, right? Gen AI RAG. One project also we saw. But how agentic RAG works? Let's say you want to understand. Then let's say some Wikipedia article is present on agentic RAG. Now you want that information. Let's say for this question you want information from the Wikipedia. Then we can define a tool. It's like at the rate tool. I'm writing a function Wikipedia 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 search. Let's say some function definition I'm writing, where user query will come here. You see here user query, and here I will do something, and I will return text something, right? I will take the Wikipedia API, and I will get the information, and I will return the text. Now this is a tool. Are you able to understand? Right? Because see, external system, external Wikipedia, this is the external thing. We want to include the information from Wikipedia into our system. Right? So we have to use tools. We are retrieving the information and perform specific actions. And we get some information, right, from this article, and LLM reasons, again, agent reasons on this. I'm interchangeably using LLM and agent, but you have to, it should be clear for you. See, agent is like the CEO, executive officer, right? CEO. And here, LLM will be there for the agent. For agent, tools will be there for agent. Some other thing, etc., etc. Now you are asking question to this agent, user query question we are giving to this user agent. Now it will give the output. No, you don't have to think what is happening here. It manages everything, right? It uses LLM to reason. It uses tools to get the external information, so that you will get the satisfied answer. Are you able to understand? Right? These are the executive board, all the people, executive board, and CEO is the one who is executing all these things based on the user query. Are you able to understand? Right? Now you can see here more of the file operations, calculations. You can write this function. You can use tools for different things, right? And weather services, email, calendar, third party APIs, anything you can define in this as a function. Anything you can define as a function, and you can use as a tool with this decorator here. Some decorator is there, right? It is a decorator which will tell the LangChain's ecosystem that this is a tool. This is no more a function. If you use this decorator, then this function is no more a normal function. It is a tool for the LangChain ecosystem, right? That's why I have defined this one. Now, custom tools, something like this, right? Now, yeah, let's move forward. Let's move forward. Yeah, you can see the analogy if you are not able to understand, right? And here something very important thing is there. Something very important. Something very important. When we are defining the tool, how it should be defined, so that LLM understands, yes, this is something is there with me which will help me. See, LLM should also understand, agent should also understand. LLM reasons that I need information about agentic RAG. Then agent should understand, yes, I have some source where I can get the information, right? You should understand. Then how you have to write the tool so that it will understand what should be the way, right? That is present in the node, important, right? Here I have defined something as important, right? That is nothing but you can see tool names and descriptions are very crucial. Here you can see here, right? LLM understand when and how to use each tool. Be clear, specific, and include examples in the docstring. Are you able to understand this statement? Why it is crucial? Because agent should understand I have some tool which will help me to solve this goal, which will help me to get the information for this query, right? For whether I will show you examples in the practical implementation. So don't worry if you're not able to get 100% here. So don't worry, we'll move forward, right? Messages in the agents. These are all very, very important. Why we need messages? Because, because let me take one example. First, let's understand what are messages. Okay, messages are communication protocol between users, agents, and tools. All agents include a sequence of messages in their state that forms the conversation history, right? Conversation history. Now, how these messages are helping the agent? Let's understand this, right? Now, let's say you go to ChatGPT and you ask, let's say this is you. Now you ask 2 or 0, which is greater? Let's say you ask, which is greater? Let's say you ask. Then AI will reply that 2. Then you say that multiply bigger with 10. Let's say this is your query. Now the human message, AI message, tool message, system message, these will help us to understand what message user has sent, what message assistant is given as output, what is the result from the tool, what is the system message that we are giving, right? All these things will help us, right? How these will help, right? Now you see here, you can see here, now I am here, bigger number with 10. Now what AI should give? AI says which number, let's say which number. Will it ask like this? Did you ever see ChatGPT asking like this? Anyone? Please respond. No, right? Because it knows the context, previous what chat history has happened. It knows that context, right? It knows that context. Means what does it mean? We are giving this chat history. This is called history, right? This is history. This is history. We are giving this history again and again for every input that we are giving. If the AI knows this, if the chat GPT knows that yes, 2 is the bigger number that we have chatted before, then it will multiply 10 into 2 and it will give 20. We are able to see this response in the chat GPT because they are providing this chat history to the agent in each conversation, that each interaction that you're doing with the model. Are you able to understand? And how this chat history will look like? History, these messages, how these look like? First, human message, I am giving something, human message, yes, this is. And then AI message, it will give something. What it will do? It will ask, okay, I need some information, and these are the tools available, agent will say. Then again tool message, tool message tool message will come like, yes, this is the information that I got using the given query. Then again AI message, yeah, this is the final answer, and we will get the output. Are you able to understand? This is what the message history contains, chat history contains. Everything will be tracked by the LangChain, so that agent will be having the complete context of what you are able to, what you are understanding, right? What you are interacting with, sorry, right? Now let's move forward. And this is how, see, user message, agent message, and tool message. Let me rub this quickly, right? Let me rub this quickly. You can see here tool message, and from the tool message we will get the tool result, right? Again agent will take the information from the tool call, and it will give as a AA message, right? Are you able to understand this? How the complete flow is, how messages are tracked, and why agent able to give responses in the context that you are able to asking, right? Now messages convert history, and this is how the short-term memory, right? Short-term memory. The short-term memory is the memory of what it has been tracked so far, the message history. And what is the state? Let me explain this with an example, right? Okay, I will take here itself. Now you see here, you see. Now let's say this is complete state. This is complete state, and here some portion is your message history. History. This is your history. This contains AI message, human message, and then tool message like this. What other things required, Jayan? If you ask me, like name of the user, like what topic he searched for. Because sometimes you go again, let's say you go to ChatGPT again, and it remembers, oh, this person has come again. Right? How? Because it also maintains some other thing other than your chat history, like your name and interactions, right? Like this. According to the use case, they remember so many other things, and all this will be included in the state. And state is the main thing for the agent. Without state, we cannot imagine the agent, right? Agent is nothing without state, because state contains everything that is required for the agent to take the decisions, it autonomously how it is taking based on this state itself, right? Now we'll see uh, quickly quickly through the practical implementation, right? I hope you are able to understand, right? You can read this. And agent versus agent executor. See, now the latest version of LangChain doesn't contain agent executor separately. Before it used to be there. Before it used to be there, agent executor. How? Let's say how it will help. It will help like this. Now you are asking query to the agent. Now agent, what is it? It is like a master. It don't do anything. What it will tell to the executor, it will tell. User given this user, agent executor, agent executor. Agent user given this query to. No, sorry, once. Sorry. First, your question will go to the agent executor. Agent executor. And agent executor will give this to your agent. And what this agent does, it agent takes a decision. Okay, this tool you call. Again, it agent will call this tool, right? And again, this tool will give some tool message, and this tool message will be updated in the chat history. And this agent executor again takes this whatever information it is present to the agent, and agent again asks my whether the user query is satisfied. No, again it will do the tool call, again tool message, and again it will update the scratchpad. We say agent scratchpad, because it contains what information that the agent needs to reason, right? It contains all the information. Means it see, from the tool we are getting some information that will be updated in this scratchpad, and this scratchpad will be given to the agent by the agent executor. Agent executor is the one who is doing all the tasks, and LLM is reasoning on that, how it decides user query is satisfied. Because you see how it satisfies. Let's say I ask let's say I ask what is the uh, population of India. Let's say this is a query, right? This is a query, and this query will be going to agent executor, and agent executor, and this agent executor writes this query in the scratchpad. This is some scratchpad, some note here, something like this I'm referring. And this note will be given to the agent, and agent, okay, I need population of India. Two things it understood, and it will search. Are there any tools? Yeah, there will be some tools, some like search tool. We will define, as I defined before, there will be some tool called search tool. We define, and this agent knows, yes, this tool is present, and this agent will call this tool, and we will get tool message, and from in this tool message it contains population of India. I will show the example and what required. And this again will be updated in the note. And again, agent execute. This will be given to the agent again. This will be again given to the agent. And it's satisfied, right? You asked population, and population is present in this node. That's it. The loop ends, and outputs. Are you able to understand, Arhant? Quickly give the message in the chat, right? Right? Are you able to understand? Like this. Yeah. Now we will see the practical implementation, right? Now we will see quickly how it works, right? Yeah, it is little tricky to rub all this, taking time. Yeah, this some other approach next time. Yeah, we'll move through the code now. Yeah, what is there? And streaming. I already told about streaming, right? Streaming is a crucial for create response algorithm. Instead of waiting for complete response, streaming delivers out progressively as it generated. I hope you watched the ChatGPT, how it is giving response. It is giving one token after one token, one word after one word. So that user don't have to wait. Instant response you will get, but you will not get completely. Did you observe that? Right? I hope you observed that. In ChatGPT, one token after one token, and complete information will be generated. And this is what streaming means. So that see, it will user sees response immediately. Progressive feedback feels more natural. See agent reasoning in real time, right? And display tools can result as they happen, right? All the information you can see, what tool is giving, what agent immediately got in the first step. There will be multiple steps agent might be taking to give the complete output. And all these steps will be, you can see all these steps, you can see just after it is taking the decision using the streaming. Now we will see the practical implementation of this, right? Now let me go to this part, right? Yeah, much. Okay. Now you see here, I'm just defining. I'm just see how you to define the tool. This is a tool definition. This is a tool definition, and I'm just importing some things, AA message, system message, all these things. And you see agent here. Create agent. Yeah, power has come. I think, yeah. Now I don't have to rush. Yeah. Now you see slowly. Here we are defining LLM, chart Mistral, and these are the messages we want to define, so that in the chart history everything will be clear. This is the message from the human, this is the message from the AI, and this is the message from the tool. All these things will be clearly written in the chart history, so that agent won't be confused. It will not get confused, it will not get any confusion when it is referring the chart history, right? Now we are defining the tool like this. And yeah, two tools we are defining. And now agent, create agent, everything. See, complete code I have taken from the LangChain agents. You just type on the internet, you will get the same thing, right? I'm not going to it LangChain documentation again, so that because we have lack of time. So now you see LLM, I'm giving the both tools, search tool and get weather tool. And I'm telling system prompt, you are a helpful assistant, be concise and accurate. That's it. And I'm telling agent doc invoke. I'm giving something like this. I have to give something like this. I'm typing here. You see, we have to give in a dictionary format. Dictionary. I hope you know, right? Messages, messages, messages. This is a key, and it contains. I'm giving a human message. Human, because I'm a human, right? So I can write like this, human message. What I am writing? What is the weather in common? Right? This is my query. This is my query. I am giving. This is my human. See, I am started my messages. I am started my message history like this. You can see here messages, human message, and for this human message, next AI message, tool message will be included. Let me run this. Let me run this. Let me run this here. Let me give some space so that you'll understand what exactly uh, agent is giving and what exactly we want from that response. And here you can see I'm running Python agent.py. Let me run this. Now you see here messages. See message, it contains content. Human, you can see from here. Where? From this is all this message only. Let me make it bigger. Okay. Yeah, this is human message. I think something was missing in this information. Okay, that is fine. See, this is human message because some it is not appearing in the terminal. So this is a human message and content. See whether this is a tool message. Okay, something was cut in between. Something was cut. Okay, let me run this again. Let me open the terminal so that new history will be there. You see here now I'm running Python agent dot Python agent dot py. What is this part? What is this? Yeah, now you can see. Are you able to see this? This part of the screen? Message. This is a complete response of the agent. What is this exactly? This is nothing but refers to basically cause and effect. So material. Yeah. Yeah, we'll conclude in 2 minutes. See here, this is a complete chart history. And from this chart history, this is our information. The weather in Khammam is currently sunny with temperature 72. How it is working? Like this. First you see here, first message, human message that we give an input, Khammam, right? And then what it is, then it is calling the tool. Where it is calling the tool? Here you can see tool, here you can see tool message. From this you got the tool message. What is the tool message? Weather in Khammam is sunny 72, right? And then agent got this tool message, then it given the agent complete response, right? 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 You can see here a message. Complete chart history is appended in this, right? Are you able to see this? Arhant, anyone having any doubt here? Anyone having any doubt here? It is giving the complete history, and from that I am just taking the last message. You can see -1 I have written here. -1 means last message that is present in the list, and from that I need content. You see, this is a message. Here you have content, right? The weather in Khammam is currently sunny with a temperature of 70 degrees. Are you able to understand? Right? This is how. This is how the tools, this is how messages, all these will help the agent to give the contextual response. Right? Now let's see how streaming works. How streaming will help us. How streaming will help us, you see. You see here. Now we have, you are writing, how we got this code, right? I just taken from the LangChain. I think you are clear with that, right? I'm not writing on my own. Everything is documented. I'm just taking from that. So we have to give like this. Messages. What is our, you can write Khammam also. Here it is San Francisco edition. You can write anything, right? Come. Now stream mode, we are taking as, we are keeping it as updates, and let me run this. Let me run. You'll appreciate what exactly happening. Now let me run it. In each step, what agent is doing, we will understand in streaming. You see, step, agent, model means agent. What it is doing, type tool call, yeah, name, yeah, something is there. and Khammam. See, what is this? What is this exactly? You see here. You see here. Now we have the agent. Now our query went to, okay, let me take some different color. Right, I'm taking white. Now you have the query. Now you are giving this to the agent. Now agent understands, okay, I have some tool. See, it understands two tools. And now it is contextualizing, means it is giving its reasoning. Using the LLM, it is reasoning like this. Because it has two tools, it automatically understanding which tool to use. Are you able to understand? Because we are given two tools, search tool and the weather tool, both we have given, but it only picked up weather tool. Why? Because our query inquires about weather, about Khammam, right? Now it is able to understand our query, and it is reasoning, and it is telling this action. I have to do this action. It is thinking and reasoning and trying to do this action. Which action? I have a tool. I have to do a tool call. This is a tool name, and this is the information required for the tool. This is very important because tools require some information, right? We have given one argument for the function, one parameter for the function is that is location, and this is the location, and this is the id where the tool is present. And now you see tool, now it called executor inside the agent. LangChain agent, there is executor I told you before, which executes this tool. Yes, type text. What is the type of that tool? Text. It will return text. What is the text? It is written whether in Khammam, right? And then we have the agent. Agent got to know, yes, he got the information. Now let me give the information to the user. Are you able to understand, Arhant? Now agent concluded because it got the information of temperature, and it was able to understand whether it is sunny. That is why it concluded. Otherwise, multiple steps will be there, right? Are you able to appreciate this? How agent is doing, right? Now I am done, right? I hope you understood complete part, how everything is working, how agents are so powerful, and how generative AI is a part of generative AI is a part of agentic AI, right? Now, I think recording is going on, right? Okay. Now, yeah, let me conclude this with the understanding of, I think I have given brief understanding of how Gen AI works, how agentic AI works, and what are the different components of agentic AI that are helping the agent to be agentic, right? Agentic means to be an agent. Agent we have. Agentic means it is behavior. The behavior, it agentic makes the agent to behave, to take action, to reason, and to give the conclusion in the loop, right? Yeah, let me stop here. If anyone having any question, then you can, Arhant, whenever query solution is present in tool message completely, that satisfy user query. Yes, correct. We can also make the agent more customized. We can define the goal for the agent so that it will understand. If some information comes to the agent, then it will automatically understand, yes, goal reached, my goal is reached. 500 words user asked, yes, 500 words are there in the tool, my goal is reached, I will stop. In the agentic AI project, you will see that customization very, very clearly, right? I'm very excited to explain that, and I hope you too, yeah, will understand more in that end-to-end project. Yeah, thank you. As many number of tools you want for your problem statement, right? Are you able to understand, Krunal? But the main point is agent autonomously understands which tool to use, right? I hope you understood, right? Any more doubts? Arhant, are you clear? If yes, please write clear in the chat so that I can move ahead. Yeah, yeah, very nice to see the doubts. Yeah, thank you.
Thank you, Jen, for giving a wonderful class.